Hello, I'm Mike McCulloch. Today I'd like to explain to you how, using quantized inertia, you could make a deflector shield. So imagine, and that's shown here in this picture, you have a spacecraft out in interstellar space, and it's traveling very fast, say half the speed of light, so that interstellar dust particles, if they hit you, they would carry a very large momentum, and you'd rather that not happen. So what you could do is take advantage of the fact that these interstellar dust particles, as soon as they encounter your ship, they would start to have a small acceleration, and that would mean that they would see Unruh waves. So what you could do is, and as is shown in this picture, you could put a ring, what you might call a ring deflector, in front of the ship, which may do two things. First of all, it could be highly conducting. It could be composed of graphene, something like that, very conductive, so that it will damp Unruh waves, and that will mean there will be an Unruh gradient in space ahead of your ship that will tend to bend the paths of the interstellar dust particles away from the ship, as shown by the dashed lines in this plot. So the actual fact that these things are very conductive would mean that the electrons in them would move to cancel the Unruh waves seen by the dust particles. Now, these dust particles, the Unruh waves seen by the dust particles will not be the same as those seen by the ship, because there will be a relativistic shift in the wavelength, so you'd have to take that into account. But if you did that, you could design something that would damp the Unruh waves and bend them away from the ship so they wouldn't hit it. The other way to do it would be to have a current within the ring that you could control, and you could vary the current in such a way that it would produce electromagnetic radiation that damps the Unruh waves seen by the particles. This would be harder because you would have to know the exact wavelength that the particles are seeing. The conductive method is more efficient, if you like, because the electrons themselves work out what the field they're seeing is and then move in response to cancel it. But both methods might be feasible. You could also use this to generate artificial gravity within a spacecraft, because you could do a very similar thing. All you have to do is damp the Unruh waves close to the floor, and people, crew members, will be pulled towards the floor. So you could have artificial gravity using quantized inertia. So I hope you've enjoyed this short and the scenery, and I look forward to seeing you next time. Goodbye.